So atomic physics radioactive source is there, which is placed 20 millimeter from a radiation detector, as you can see. What is the purpose of this lid, which is having a one opening? You cannot say it is used to block the source. Why you cannot say? Because it's not a complete solid object. There is an opening. What is the purpose of that lead with the opening? Small hole. Yeah, to make a beam or to collimate the source. Collimate means like focus the source in one. To make sure that's right, to make sure it will go in one way, that's why we use a lead box, lead metal with a small opening. To produce a narrow beam, to make a beam source, that's good. The initial count rate detected by the detector is 150 counts per second. A sheet of a paper is placed and the count rate recorded fall to 60. Like it was recording 150. When we place a paper, the count rate reduced to 60. What we can say about the source emission? What kind of radiation is there present? Is there an alpha? Yes, because so alpha is there because the paper reduced the count, so there is an alpha. The next part, yeah, it includes an alpha, that's right. With the paper still in place, the magnetic field is set up and the counts of a count rate of a detector falls to 20, which is also a background. So first what happened, like it was giving 150 radiations without any paper. We place a paper, the count has reduced to 60. We apply the magnetic field. We did not mention whether it is in or out, but we apply in a region, we apply the magnetic field. So when we apply the magnetic field can cause a deflection to both alpha and beta. Gamma cannot be reflected. So the counts, if it was, so it means there was a beta because the counts now has reduced from 60 to 20. So if the counts reduced from 60 to 20 means there is also a beta. And the paper shows there was alpha because it was reduced. The deflection shows there is beta as well. But and the 20 counts are due to background as well. So is there a gamma? No, because if there was a gamma, then the count should not be 20, it should be more than, it should be above the background. So state the evidence, which type of radiation present or absent. Alpha, what we'll say? Present. And why the alpha is present? Because the paper reduce the counts. Beta, present because the magnetic field changes the count. Gamma, not present. Why? Because the counts are same as the background. When there is a magnetic field, the counts are same as the background, so there is no gamma. Determine the count rates. Use a screen annotation. Determine the count rate. This was the first paper, it reduced to 60 and then that was 20. How many radiations are due to alpha? So determine how much the original count rate of 150 is due to each type of radiation. So first we were having 150. This 150 include what? Alpha, beta, and the background as well. So here, as you can see, like the marking scheme answer is already given. So originally it was 150, but when we place a paper, it reduced to 60. So how much? That is 90. Then the 60 was there. When we apply a magnetic field, it reduced to 20. So how many beta are there? Due to beta 40. And then the remaining gamma, there will be no gamma, 0. And actually that was a background which is 20. So 20 plus 90 plus 40, the total sum will be, it should be 150. So this was one question from Atomic. We have this page 2. To ensure the safety of the worker in the lab when a radioactive source is used, uh, where how radioactive source should be stored. So it should be in a lead line box. Good. So we should have a lead line box or a lead line container. And how it should be handled? Lead gloves, long tongs. Tongs is much better, like how it should be handled. Long tongs should be there. Part B, complete the table. Use the screen annotation. The first one is electromagnetic radiation. You can mention the name, or you can just use a symbol. Gamma is there, and it can be absorbed by lead. The second one is alpha, can be, which is a helium nuclei. What is the range of alpha? Which is few centimeter, and it can be stopped by a paper. And for beta, it is a fast moving electron. Um, and can be stopped by aluminum or thick aluminum. Here you can see a few meters are there, and thin aluminum or thick lead is there. Thin aluminum, it should be thin. For here the last part, if you just mention aluminum, but it should be thin aluminum. Americium is there, 241, and 2 changes to 237. Which emission is this? The nucleon number decreases by 4, so it's alpha. And here the nucleon number does not change and the proton number increases by 1. So which emission is this? It is beta. So this was atomic physics, page 1, 2, and 3.